In this video, we're going to continue review of the practice final test, and Jack and I will take you all the way through to the end with this part 2 video. We left off on number 23, and indeed this is an order of operations procedure. So recall the acronym was PEMDAS, standing for parentheses, exponents, multiplication and division, and addition and subtraction. So notice, folks, I grouped these together. That's because multiplication and division have the same priority. Addition and subtraction have the same priority. You determine which to do first based on moving left to right when you're dealing with multiplication and division and addition and subtraction. For example, if you have this listed, you do this division first before that multiplication. So even though it looks like division is listed after multiplication, that is not how it works. If you have multiplication and division in the same expression, you go left to right like you're reading a word. Okay, so if you're going to read the word Jack, you're going to go from left to right. That's how you do this. Okay, similarly, if you had an expression where you have even though it looks like addition comes before subtraction in the word PEMDAS, that's not how it works. These have the same priority. So when you have when you have subtraction and addition in the same expression, you go left to right. So here you would do subtraction first. You would do 6 minus 3 is 3, plus 8 equals 11. Over here on the left side, I forgot to go ahead and complete this. You would have 6 divided by 2 is 3, times 4 equals 12. That's how you do these. So PEMDAS is a little bit confusing when you're talking about multiplication and division and addition and subtraction. To review, they have the same priority, they have the same weight. And when you have them together, you take whatever comes first and do it that way. Okay, that's enough of that. Hopefully it'll become clear during the examples. Okay, this first one, we have addition and division. So we know, let me keep PEMDAS on my screen if I can. We know that clearly division comes before addition and subtraction. Okay, again, I'd like to group these together because they have the same priority. Okay, so we're going to divide first. 96 divided by 2 is going to be 48, and then we're going to add 8, and we're going to get 56. Okay, so let's review that. 8 plus 96 divided by 2 equals. Okay, division comes first, so we're going to do 96 divided by 2. That's going to be 48. And then we're going to add 8 to that, and we're going to get 56 as our final answer. Next one, 24. Okay, another order of operations. Here we have 8 times 9 plus 8 minus 9. Okay, so we're going to do multiplication first. 72. we have addition and subtraction. They have the same weight. So when you have addition and subtraction, you go left to right, first come, first served. So 72 plus 8 is 80, minus 9 is going to be 71. There's your answer. Next one. Okay, more complicated here. So let me write this down. Here we go. Okay. So folks, we have parentheses, we have an exponent, we have division, and we have addition. So let's do the parentheses first. 24 minus 4 is going to simplify to 20. Let's then do this exponent. Okay, what is 1/2 squared? 1/2 squared is 1/2 times 1/2. And again, folks, when you have fractions, you multiply straight across, and that's going to be 1/4. Okay, so let's take that, bring that up next to the 20. Okay. Get rid of this. Okay. Now, we do not add 36 yet. What we do is we respect the fact that the division takes precedence. And we do 36 divided by 3, and that's going to give us 12. Okay, so 36 divided by 3, if that's not immediately obvious to you, do a quick division. I may have mentioned in class, this is how I like to set things up. The numerator, the numerator topples in to the shoebox. I put a decimal point and 3 zeros. I may or may not need the 3 zeros. The decimal point up top goes straight above it. Okay, let's get rid of that toppling arrow. And then we do our division. 3 goes into 3 once. We check this number, make sure it's lower than the divisor. If it is, then we know we have the correct number here. Bring down 6, and we get 2, and that's our final answer. So 36 divided by 3 becomes plus 12. Okay, so now we have a brand new problem. 20 times 1/4 plus 1/2. We respect the PEMDAS order of operations now for this step 2. Okay, let me get rid of some of this busyness here. Oops, I don't want to do that. I'm sorry, folks. Getting too fancy, I should just do this. Okay. So now we have this expression. So what are we going to do first here? We're going to multiply 20 times 1/4. Okay, when we do that, we bring these a little bit closer together, like that. We know we can rewrite 20 as 4 times 5. Because these 4s, one is on the bottom, one is on the top, they can cancel. So 20 times 1/4 ends up being 5. Five plus 12 is 17. That is your final answer. That's what you would write in. Okay, so let's review what we did. First, we got to make sure we transcribed it correctly, and we did. Parentheses, 24 minus 4 is 20. Exponent, 1/2 times 1/2 is 1/4. 36 divided by 3 is 12. 20 times 1/4 is 5. 5 plus 12 is 17. Okay. Next, evaluate this expression for x equals 3. So it looks like we're done with PEMDAS for a little bit. Let me write this down. Okay, for x equals 3. Whenever you're asked to evaluate an expression for x equals something, you take this number and you substitute it everywhere you see an x. Okay, so for example, in this particular problem, everywhere we see an x, we're going to put 3. So it turns out it's only in one spot. So this becomes 5 times 3 plus 3 minus 6. 5 times 6 minus 6. 30 minus 6, or 24, is your final answer. Let's see if it's there or if that's a right end. Nope, it's right there. Choice 2. Next one. How many terms does this expression contain? Well, the answer is 3. Each of these are terms. Whenever you have something separated by a plus or a minus sign, that's a term. So the answer to this is 3. Next one. Is this equation true or false? Let's look at this. Let me rewrite it. Okay. Ladies and gentlemen, when you have common bases and you're multiplying, you are allowed to add the exponents. So if I put a hidden 1 here, the way to approach this problem is to, when you're multiplying, you have a common base, the same base, you add the exponents. So this becomes x squared, because 1 plus 1 is 2. It is not equal to x cubed. So this is a false. This was false. In other words, x times x does not equal x to the 3rd. Okay, let's do another one. If you have x squared times x, what would that equal? You have the same base, namely x. You're multiplying, therefore you are allowed to add the exponents. There's a hidden 1 there, so this would become x cubed. Next one. Solve for x. Okay. We have x plus 67 equals 100. Our goal is to solve for x. Whenever you see those words, solve for x, that means we have to get x by its lonesome. In other words, we have to get something like this. X equals something. X cannot have any neighbors. So if you were to draw a circle around the side of the equation that contained x, there would be nothing with it except the hidden 1 that's with it. Or if you want to put a hidden 1 below, that's okay, but nothing else. You can't have plus 67. You have not solved for x. Here's some other examples where you have not yet solved for x. If you have 3 times x, that is not solved for x. If you have 2x minus 8, you have not solved for x. You have to be able to put a circle around it and only have x or positive 1 times x. Okay, so how do we do that? How do we get rid of this neighbor? Okay, we know that if we were to draw a circle around this side of the equation, we have not yet solved for x because that plus 67 is there. So here's what we do. We look at the operation that's being done between x and its neighbor. In this case, it's addition, and we do the opposite. Okay? So So what we do is we come along and we subtract 67. Subtraction is indeed the opposite of addition. When we do that, when we take positive 67 minus 67, this reduces to 0. And that was by design. So now this becomes x. However, we have to do the same thing to the other side of the equation. And that's because when we started out this problem, we had an equal sign. And if we come along and do minus 67 on this side, that equal sign would no longer be valid. So we have to do the same exact thing on the opposite side. So 100 minus 63, 100 minus 67 is going to end up being 33. And that is our final answer. That is our final answer, x equals 33. Okay, let's move on. Similar problem. We have x minus 72 equals 112. X is not by itself, it has a neighbor. The neighbor's being subtracted from x. The way to neutralize that 72 is to add 72. When we do that, this reduces to 0 and we have x isolated. However, we have to do the same exact thing to the opposite side to maintain the integrity of that equal sign. And there's our final answer, x equals 184. And there it is, choice 2. Okay. Select all the values that make this true. Y is less than 6.29. So which of these are less than 6.29? Okay, 6.7 is greater. Okay, it looks like only these two, because 6.29 would be equal, not less than. So it looks like 6.28 and 6.09. Okay, another percent question. So here you have your choice to either do it using a fraction or a decimal. Have to be good at this, have to be adept at taking percentages to excel in math. 12% of 62. I'm going to do it both ways, fraction and a decimal. Here we go. Can't work with that percent sign. We're going to change it to 12 over 100. The of becomes a multiplication sign, and then you have 62. 62 over 1 makes things easier when you're looking at this fraction. Okay, so how would we reduce 12 over 100? Well, 12, you always do the smaller number first. 12 can be reduced to 2 times 6, and 100 is 2 times 50. That crosses out. 6 can be reduced to 2 times 3. 50 can be reduced to 2 times 25. So now you get 3 over 25. I'll take that. I'm going to take 3 over 25. And I'm going to replace, whoops, I'm sorry folks. Like so. Okay. I don't think you can reduce that any further, because 62 is going to be 2 times 31, 5 times 5. Okay, so here's a case where fractions were not very helpful. All right, so I'm going to regroup, and we're going to use decimals. Again, I want you to know how to do both, but it's late in the year, so whatever's easier for you, you can do. Okay, 12%, what is that in decimal? Okay, you can start off by saying it's 12 over 100. So that's going to equal 0.12, right? That's 12 hundredths. Of is being multiplied. So we're going to take the 0.12 and we're going to multiply it by 0.62. See where that takes us. It's 2 digits to the right of that decimal point. That means we got to move this 2 places. So our final answer is going to be 7.44. That's what you would write in for that one. Okay, how about this next one? 1 second. How about this next one, folks? Solve for y. Okay, pretty straightforward. We've been doing these. So this should be relatively quick. Are we solved for y as is? Answer no. Because if I put a circle around the side of the equation that has the variable, it has a neighbor. What is that neighbor being, what's happening? What's the operation between the variable and the neighbor? It's multiplication. It's addition. So how do we neutralize it? Subtraction. This becomes 0. That equal sign mandates that we do the same thing to the opposite side. We end up with y equals 13. Okay, another percent. Folks, I think I've learned my lesson on this practice test. I'm going to go right to decimals on this one. 64% of 80 is going to be 98, I'm sorry. 64% is going to become 6,400. We're going to change that to 0.64, and we're going to multiply that by 98. There's your final answer. Next one. Solve for x. Same thing, folks. We have x minus 9 equals 22.5. How do we get rid of that minus 9? We add 9 to both sides. This cancels out, and you're going to get $31.5. Okay, I think it was helpful to put 9.0 there to line things up when we added those decimals. There's your answer, the first choice. Solve for x. I'm not even going to write it out. We're going to add 5 to both sides, and we're going to get x equals 94. Okay, here's another PEMDAS. Okay, we're almost done, folks. Here we go. We're going to evaluate this. Let me write it in. Okay. Multiplication is going to take precedence over addition and subtraction. 10 times 7 is 70. 6 minus 3. When you have subtraction and addition, you go left to right in order. 6 minus 3 is going to be 3 plus 70 equals 73. That's your final answer. Okay. Paul scored more than 6 points in each of his basketball games. Which of the following best represents the number of points that he scored in any one game? Okay, notice it says more than 6. Not more than or equal to 6. More than 6. So it has to be this one. Can't be greater than or equal. Next one. What is the area of this parallelogram? The formula for parallelograms is 8 times 15. Sorry. $15 times 8. $120. The units are square because we're dealing in areas. What is the area of the triangle? Formula for triangle, ladies and gentlemen, is 1/2 base times height. So we are going to have 1/2 base times height. We can put these in fractions to make things easier. If we bring things closer together, if I write this as 1/2 times 4/1 times 2/1, we see that these 2's can cancel out because one is on the top, one's on the bottom, and everything is being multiplied. So our final answer is going to be 4. Okay, next one. Area of a trapezoid. Okay, you definitely will see this on your final. Area of a trapezoid is found by getting the average of the bases and then multiplying it by the height. This value here is irrelevant. You do not use this at all in the computation of the area of the trapezoid. It's just the 2 bases and the height. Okay, how do we get the average of 2 things? We add them and divide them by the number of items. Okay, let's see if we can go like this for this one. Okay, good. So, here's one base, here's the other. We're going to add them and divide by 2. So we're going to get 12 divided by 2 equals 6. Then we're going to take that and multiply it by 9. And our final answer is going to be 54. There it is, choice 2. Here's another trapezoid. Let's go side by side again. That worked. The formula, you get the average of the bases. You do that by adding them and dividing by 2. Then, once we have the average of the 2 bases, we multiply by the height, and we get our final answer. Remember, the units are squared because we're dealing with area. First thing you do, get the average of the bases. You add them, and divide by 2, that's what we did. They add to 12, divide by 2 is 6, multiply by 5 is 30. Okay. Let's look at this one. So here we have to be careful. We have to use the order of operations within the parentheses. Okay, we know that we have to do the parentheses first. Okay. Always double check your transcription is correct. Okay. Whenever you have multiplication and division, you go in order. They have equal priority. Okay, so we have 9 times 5 is 45. Divided by 3 is 15. So we have 6 plus 15 squared. I happen to know that 15 squared is 225. We add 6. Final 231. Next one. Evaluate this for x equals 2.2. Okay, folks, whenever someone tells you to evaluate something for x equals something, everywhere you see x, you plug in that number. So what we're going to do is take 2.2 and plug it in there for x. So we're going to end up with 3 times 2.2 which is going to be 6.6, and then we are going to add 7. Again, when you're adding decimals, it's easier to put the point 0 like that. 13.6 will be your final answer. There it is, choice 2. Okay? Here we have a movement question. All right. They don't give you a grid. So here we go. They don't give you a grid, draw your own. You start at 4, 5. Remember, the first number is the x value. So 4, 5 would be right about there. That's 5 and that's 4. This is 4, 5. And now you move up 2 units. So you end up there. Your x value stays the same because you're not moving left or right, you're going straight up. So whenever you go up or down, it's your y value that changes. So this final answer is going to be 4, 7. Here, let's do it down here on this grid. Okay, 4, 5 would be right there, and now you go up 2 units. 1, 2, this would be 4, 7. Okay, we're on 46 now, might as well stay here. If we reflect point H over the y-axis, what would the resultant point be? Okay, here's your y-axis. You want to recreate this point on the other side of that line. It's going to be right there. So that would be 1, 4 would be your final answer, right where my cursor is. Next one, another movement problem. You start at 8, 3. Okay, so here we go. 8, 3. You move to the right 1 unit. Okay, so now we're not going up or down. We're moving to the right 1 unit. So that's going to be 9, 3 right there. Let's do that again. Start at 8, 3. So you got to get to the right spot. 8, 1, 2, 3 right there. You move to the right 1 unit. That's where you end up. That would be 9, 3. True or false? Okay, we had one of these earlier. Let me rewrite it here. We have x times x squared equaling x to the 4th. I'm going to put a question mark because we don't know if it's true or not. Don't forget, these x's have hidden ones. When you have a common base, you are allowed to add the exponents. So this becomes 1 plus 1, which is 2, plus 2 is 4. So yes, that's a true statement. Solve for z. Whenever you see something like this, solve for z. You take this and you put it everywhere you see a z. As it turns out, there's only one spot. When you multiply 3.3 times 7, you end up with, let's do that together. Okay, now what to do with the decimal point? How many digits are to the right of that decimal point? Answer 1. Therefore, you take this and you move it 1 spot. Your final answer is 23.1. Now you subtract 3. Again, when you're adding decimals, I think it's helpful to line it up like that. Instead of just 3, put 3.0. It just helps me. 20.1 is your final answer. Right there, first choice. Area of the rectangle, pretty straightforward. Length times width, 36 square units. We are done.